right, so we're diving into deep sea chemistry today for this deep dive.
Okay.
You sent over some really cool stuff on hydrothermal vents and extremophiles.
Oh, yeah,
The life forms that just laugh in the face of conditions that would just obliterate us, like, immediately.
Yeah, they're incredible. Really makes you wonder, like, how much we really understand about where life can exist, We spent centuries thinking that sunlight was the VIP, the key to all life's parties, and then...
Yeah, photosynthesis, right. Like, that's what we learned in, like, 6th grade, right?
Yeah, totally. Photosynthesis, that's how life gets energy. But then along come these hydrothermal vents, and suddenly the textbook needs, like, a major rewrite.
Right.
So picture this, okay? Underwater volcanoes, like something straight out of Jules Verne, spewing these superheated, mineral-rich fluids, like we're talking over 400 degrees C. That's hot enough to melt lead.
Yeah.
And guess what? Life doesn't just survive there, it's thriving.
Thriving. Wow. Yeah, that is mind-blowing. It's like finding an alien civilization just hanging out at the bottom of the ocean.
I love that analogy. That's a great one. And the party animals down there, we call them extremophiles. So these organisms, they don't just tolerate these insane conditions. They actually need them to survive.
Right.
Crushing pressure, scorching heat, toxic chemicals, it's all part of their, like, daily routine.
Wow. Okay. So how do they pull that off? I mean, we land dwellers, we need sunlight, like we need air. How can anything survive without it?
That's the truly wild part. They've completely ditched the whole photosynthesis playbook. They've invented their own game, and it's called chemosynthesis.
Chemosynthesis. Okay, I've heard that term, but break it down for me. What's the secret recipe? Like, how does it actually work?
Okay, so these clever organisms have figured out how to convert chemicals from the vents. So things like hydrogen sulfide, methane, iron into energy. So it's like photosynthesis, but instead of basking in the sun, they're having a chemical feast.
So they're tapping into Earth's internal energy instead of relying on the sun.
That's so cool. It is really remarkable. It's like a completely different way of life. And it's built the foundation for a whole ecosystem down in the deep, dark ocean.
Yeah, this is where those giant tube worms and all those crazy, like, deep sea creatures come in, right? Those ones that look like they just stepped off a spaceship, like in those nature documentaries.
Oh, yeah. You got it.
Yeah.
They were just a small sample of the biodiversity that's happening around these hydrothermal vents. And that whole ecosystem, from the tiny bacteria at the bottom of the food chain all the way up to the larger predators, is powered by chemosynthesis. No sunlight required.
It's like a secret society. Like a whole hidden world down there. It just makes you wonder what other secrets are lurking down there.
Exactly. And here's another wild card. Have you heard about the formation of, like, unique metal deposits around these vents?
Oh, yeah.
Yeah. Imagine, like, Mother Nature is running her own high-pressure laboratory, creating materials that we can only dream of, like synthesizing here on land.
Oh, wow. Hold on. So not just crazy life forms, but potentially, like, game-changing materials, too.
Yes. It's a gold mine in more ways than one. Scientists are, like, going crazy studying these natural processes, trying to figure out how to mimic these conditions, these high-pressure, high-temperature conditions, to make new, super advanced materials.
Like, are we talking spaceships and supercomputers and, like, bionic limbs? What kind of stuff?
Potentially all of the above. Think of materials with, like, crazy strength and durability and conductivity, all inspired by those metal deposits that are formed around hydrothermal vents. It's like the perfect example of how exploring, like, the most extreme corners of our planet can lead to these breakthroughs we never even saw coming.
So we're not just, like, decoding the secrets of life in the deep, but we're also potentially, like, unlocking the secrets to revolutionizing, like, all kinds of industries up here on the surface.
That's the idea. It's pretty exciting stuff, and it goes even deeper than that. Understanding these extremophiles, understanding chemosynthesis could also be a game changer for fields like biotechnology and even, wait for it, the search for extraterrestrial life.
Whoa, hold up. Aliens. How does deep sea chemistry lead us to eat?
Think about it this way. The environments around these hydrothermal vents, they're like a sneak peek into what conditions might be like on other planets, other moons. Places like Jupiter's moon Europa or Saturn's moon Enceladus, they're thought to have, like, these subsurface oceans that might be home to similar hydrothermal activity.
So if these crazy life forms are thriving on chemical energy down here in Earth's deep sea, then maybe, just maybe, there are similar life forms partying it up in those alien oceans too.
It's a pretty mind-blowing possibility. It really makes you think. And by studying these extremophiles and their crazy biochemistry, we're basically getting a glimpse into what alien life might look like. It's like having a backstage pass to the universe's weirdest concert.
No, that's something I'd love to drop at a cocktail party. Like, hey, did you know about those, like, alien-like creatures throwing a chemical rave at the bottom of the ocean?
Yeah, that's a conversation starter for sure. And it just reminds us that even on our own planet, there are still these incredible secrets waiting to be discovered. The more we explore these hidden worlds, the more we realize just how much we don't know about the potential for life, both here and out there in the cosmos.
You know, it's funny. We started with hydrothermal vents, and now we're talking about aliens. It's like falling down a rabbit hole of scientific wonder.
I know, right? And that's the beauty of exploration. It's a journey without a final destination. And each discovery is just the beginning of a new chapter. Who knows what other mind-blowing revelations await us in the depths of our oceans and beyond.
It's enough to make anyone want to, like, trade in their cocktail glass for a scuba tank and go exploring those underwater volcanoes for themselves.
Yeah, just be sure to pack a heat-resistant suit. Those 400 degrees C waters aren't exactly pool party friendly.
Good point. I'll stick to my cocktails and let the extremophiles have their fiery dance floor. But seriously, it's amazing how deep-sea chemistry can, like, spark our imaginations and make us rethink the possibilities of life itself.
It really is. It's a powerful reminder that the most extreme environments often hold the most extraordinary discoveries. Who knows what other secrets are waiting to be uncovered in the depths of our planet and beyond?
Well said. So to sum it up, studying hydrothermal vents and extremophiles isn't just about cool deep-sea creatures. It actually has major implications for fields like material science, biotechnology, and even the search for extraterrestrial life. It's like a scientific buffet with something to blow everyone's mind.
Exactly. And what's really exciting is that we've only just scratched the surface. Imagine the potential for new discoveries as technology advances, and we're able to explore these extreme environments in even greater detail.
It's like we're entering this golden age of deep-sea exploration. The bottom of the ocean is becoming just as fascinating and full of potential as outer space.
I couldn't agree more. The age of deep-sea discovery is just beginning, and who knows what mind-blowing wonders are waiting for us down there.
I, for one, can't wait to find out. But before we get too carried away with visions of alien oceans, let's take a closer look at some of the specific extremophiles we've discovered around those hydrothermal vents. You mentioned those giant tube worms earlier.
Oh yeah, those giant tube worms, they're like the true icons of these hydrothermal vent ecosystems. They can grow to over 6 feet long, and here's the kicker. They don't have a mouth, a gut, or a digestive system.
Wait, what? No mouth. How do they eat? Do they, like, just absorb nutrients through their skin or something?
That's where things get really interesting. They have this amazing symbiotic relationship with bacteria that live inside of them. So the bacteria, they perform chemosynthesis, they use the chemicals from the vents to produce energy, and then the tube worms, they get their nutrients directly from the bacteria.
So it's like they have their own personal chefs living inside of them? That's way cooler than ordering takeout.
It is, and it's a prime example of like coevolution and interdependence in these extreme environments. And speaking of extreme, another remarkable resident of hydrothermal vents is the Pompeii worm.
Pompeii worm. That sounds kind of ominous.
Yeah.
Is it like buried under volcanic ash or something?
It's actually named after the ancient Roman city of Pompeii because it can withstand incredibly hot water. We're talking up to 80 degrees C. That's almost boiling.
80 degrees. It would be cooked in seconds. How on earth can anything survive in that kind of heat?
That's what makes the Pompeii worm so fascinating. It has this thick, protective layer of bacteria on its back that acts like insulation against those, like, scorching temperatures. And get this, these bacteria also seem to play a role in providing the worm with nutrients, too.
Wait a minute. So this is another example of, like, teamwork, but this time it's about protection from heat instead of food.
Yeah.
It's like a tiny, underwater, heat-resistant apartment complex.
It is, and here's the real kicker. Those bacteria, they're producing these unique compounds that scientists are studying for potential medical applications.
Okay, so now we're back to those, like, scientific breakthroughs. What kind of medical wonders are we talking about? Are we close to a cure for the common cold yet?
Well, some of the compounds produced by these heat-loving bacteria have shown like antibacterial and antifungal properties. So yes, they are being investigated for their potential to develop new antibiotics and other life-saving drugs.
Wow, so these tiny bacteria just hitching a ride on the back of a Pompeii worm could hold the key to fighting, like all kinds of infections. That's a plot twist worthy of a sci-fi novel.
It is. It's really quite remarkable, and it just goes to show you that nature is full of surprises. Even the most seemingly inhospitable places can harbor secrets that could benefit all of humanity.
It makes you realize there's a whole universe of possibilities waiting to be discovered right beneath our feet, or in this case, beneath the ocean waves. Who knows what other amazing discoveries await us in the deep sea?
It's truly an exciting time for exploration and discovery. There's so much more to learn.
Absolutely.
Welcome back to our deep dive into the world of hydrothermal vents and extremophiles.
We've already covered some seriously mind-blowing stuff. Chemical feasts, giant tube worms, even the possibility of alien life out there.
I know, right?
But we're just getting started, right?
We're just getting started. There's so much more to uncover about these incredible ecosystems.
So where do we go from here? What other crazy adaptations have these extremophiles, developed to survive in these, like, really harsh conditions? We talked about the heat, we talked about the chemicals, but what about the pressure? I mean, these vents are like miles below the surface.
Right. Oh, you are so right. The pressure down there is absolutely crushing. I mean, we're talking hundreds of times greater than what we experience at sea level.
Yeah. I tried scuba diving once, and my ears popped at, like, 10 feet.
Right.
I can't even imagine what it would be like down there.
Yeah.
I'd probably just implode.
Yeah, you and me both.
Yeah.
But extremophiles, they have evolved to not just withstand that pressure, but to actually thrive under it. Their cellular structures, their enzymes, they've all adapted to function perfectly in those extreme conditions.
So they're basically like, bring on the pressure. Is that all you got?
Yeah.
It's amazing how life finds a way.
It is truly remarkable. And then there's the issue of pH. The fluids that are spewing from these hydrothermal vents, they can be highly acidic or alkaline.
Oh, wow. So not only are they dealing with pressure that would crush a tank, but they're also swimming in water that could, like, melt your face off. These creatures are hardcore.
I know, you said it. But they've developed these incredible mechanisms to regulate their internal pH, to protect themselves from those, like, really harsh chemical conditions. Some of them even use those extreme pH levels to their advantage.
Really?
Yeah.
Like, how are they brewing some secret potion down there or something?
Well, certain bacteria, they've evolved to actually thrive in extremely acidic environments. And get this, they actually use the acidity to generate energy. It's like their version of a power drink.
It's like life gave us lemons, so we made a battery.
That's a great way to put it. Yeah, it's another testament to the resilience and the diversity of life on Earth.
And it makes you wonder, if life can exist in these insane conditions, what are the limits of life itself?
That is a question that scientists are still trying to answer. The study of extremophiles is constantly pushing the boundaries of what we thought was possible. And it's not just about understanding life on Earth. Remember, this has implications for the search for extraterrestrial life, too.
Oh, yeah, that's right. If life can exist in these crazy conditions here, it's not so far-fetched to think that maybe, similar life forms could be hanging out on other planets or moons out there facing similar challenges.
Exactly. It opens up this whole new realm of possibilities for where we might find life beyond our own planet.
So maybe those sci-fi movies about aliens living on planets with, like, lava rivers and acidic oceans, maybe they're not so crazy after all.
You never know.
Pretty excited to think about.
It definitely is. And it just, underscores the importance of exploring and studying these extreme environments, both here on Earth and beyond.
Well, speaking of exploring, let's shift gears a bit and talk about the practical applications of studying extremophiles and hydrothermal vents. You mentioned earlier that scientists are using them to develop new materials.
Yeah.
Fill me in on that. Like, what kind of cool stuff are we talking about? What are they doing with this information?
Well, remember those unique metal deposits that we talked about earlier?
Oh, yeah.
They're formed under those crazy high-pressure, high-temperature conditions around hydrothermal vents.
Yeah.
They have some pretty amazing properties.
So it's like nature's own pressure cooker is creating these super materials for us. That's pretty handy.
I know, right? It's
Yeah.
pretty amazing. For example, scientists have discovered a material called biogenic iron sulfide that forms in these environments.
Biogenic iron sulfide.
Yeah.
Okay. Sounds impressive. But in layman's terms, what's so special about it? What can it do that, like, other materials can't?
Well, it's incredibly strong and lightweight and also corrosion resistant. Imagine the possibilities. Scientists are investigating its potential use in, all sorts of applications, including aerospace and construction.
Whoa. Are we talking airplanes and skyscrapers made out of, like, bacteria poop?
Not exactly poop, but you get the idea.
That's wild.
It's a naturally occurring material formed with the help of bacteria, and it has these incredible properties, and the possibilities don't stop there. Some of the enzymes that are produced by extremophiles are also being studied for their potential use in industrial processes.
Enzymes, huh? Okay, break it down for me. What kind of, like, industrial magic can these enzymes perform?
Okay, well, for example, some of these enzymes can function at like incredibly high temperatures.
Oh, wow.
This makes them ideal for use in processes that require a lot of heat, like the production of biofuels or the breakdown of like really tough pollutants.
So we can potentially use enzymes from extremophiles to, like, create cleaner energy and clean up the environment.
Exactly.
That's a win-win.
It is. It is a win-win. And there are countless other potential applications being explored. Some extremophiles produce enzymes that can break down plastics. Others can be used to create new types of adhesives or coatings. The possibilities are really endless.
It's mind-boggling to think that these tiny creatures, living in such extreme conditions, could hold the solutions to some of humanity's, like, biggest problems.
I know. It just goes to show you that nature is a very powerful force and that we still have so much to learn from it.
It's like these extremophiles are saying, hey, humans, we've been thriving down here for millennia, dealing with pressures and temperatures you can't even handle. Maybe you could learn a thing or two from us.
Exactly. They're living proof that solutions often come from the most unexpected places.
Speaking of unexpected places, let's talk about some of the more recent discoveries related to hydrothermal vents. I read somewhere that scientists have been finding new vent systems in some pretty surprising locations.
Oh yeah, that's right. We used to think that hydrothermal vents were mainly found along mid-ocean ridges where tectonic plates are spreading apart.
Those are the underwater mountain ranges, right? Like the seams of the Earth's crust.
Exactly.
Yeah.
But in recent years, we've been finding them in other places like near volcanic islands and in subduction zones where tectonic plates collide, and even in the middle of continents.
Wait, so hydrothermal vents aren't just an ocean thing? They can be on land, too.
Well, not exactly on land, but they can be found in lakes and rivers that are heated by geothermal activity.
Wow.
It's like finding a hidden oasis of extreme life in the most unexpected places.
This is getting better and better. So it seems like hydrothermal vents are more widespread than we initially thought.
It definitely seems that way. And each new discovery brings with it the potential for finding new and unique life forms and materials.
It's like every time we find a new vent system, we're opening a door to a whole new world.
Exactly. And it just goes to show that we still have so much to learn about our own planet.
You know, after hearing all this, I'm starting to feel like we land dwellers are the weird
I
ones.
know, right?
The extremophiles are the ones who really know how to party.
I know. They're living it up down there.
Well, on that note, I think we need to dive even deeper into some of these new discoveries and what they mean for our understanding of life on Earth and beyond. Let's take a closer look. Okay, we're back and ready to wrap up our deep dive into this wild world of hydrothermal vents and extremophiles. It's been quite the adventure.
Oh, it really has. From like crushing pressures and scorching temperatures to chemical feasts and the possibility of like alien life. We've covered so much.
And we've learned that these extremophiles aren't just surviving, they're like thriving in conditions that would make us land dwellers, just wilt faster than a lettuce in a sauna.
Oh, absolutely. They're a testament to the adaptability and the resilience of life itself. It's pretty amazing.
But before we resurface from this deep dive, I'm curious about something. We've talked a lot about the unique life forms and the materials that are found around these vents, but what about their impact on the larger ocean ecosystem? They seem so isolated, like miles below the surface. Do they really play a role in the bigger picture?
That is a great question, and the answer might surprise you. Hydrothermal vents are actually incredibly important for the health of the entire ocean.
Really?
Yeah. So think of them like underwater oases. They're constantly pumping out nutrients and minerals that support life throughout the ocean.
So those vents are like the ultimate life support system for the ocean. That's a pretty big responsibility for those deep sea smokers.
It is, and it just highlights how interconnected everything is on our planet, right? What happens in the deepest, darkest parts of the ocean can have these ripple effects that reach all the way to the surface and beyond.
Yeah, that's a powerful thought. It makes you realize we need to understand and protect these ecosystems, not just for the sake of the creatures that live there, but for the health of the entire planet.
Absolutely. And unfortunately, that brings us to another important point, the potential threats facing these unique ecosystems.
Oh no. Not threats. What's endangering these amazing underwater worlds?
Well, just like so many other natural wonders, human activity is putting increasing pressure on these hydrothermal vent ecosystems. One of the biggest concerns right now is deep sea mining.
Deep sea mining. Yeah, I've heard about that.
Yeah,
It's all about extracting those valuable minerals, right? Like we talked about earlier.
exactly. As we discover more and more valuable minerals around these vents, there's growing interest in mining them for, like, commercial use. But those mining operations could potentially damage or even destroy these fragile habitats with, like, unknown consequences for the life that depends on them.
Yeah, that's a tough situation. I mean, those minerals could be used to create new technologies and products that could benefit humanity,
Yeah.
but but at what cost? It's like we're constantly faced with this dilemma of balancing progress with protecting the environment.
It is. It's a really complex issue, and it's a conversation that needs to happen on a global scale as we continue to explore and exploit the resources of the deep sea.
And it's not just mining that's a concern, right? Climate change is impacting the entire planet, including the oceans. I bet those hydrothermal vents are feeling the heat too.
You're absolutely right. The ocean absorbs a significant amount of the excess heat and carbon dioxide that we're pumping into the atmosphere, and this is leading to ocean acidification and rising water temperatures, which can stress or even kill off sensitive deep-sea species.
It's a sobering reminder that our actions have far-reaching consequences, even for those seemingly remote underwater worlds. It feels like we're playing this high-stakes game with our planet, and we're not even sure what the rules are.
It's a wake-up call, for sure. But there's hope. There's incredible work being done to better understand and protect these vulnerable ecosystems. For example, scientists are developing new technologies to explore and study these environments in greater detail than ever before.
Oh, like what? Are we sending, like, robots down there to hang out with the giant tube worms?
We're not quite at the robot party stage yet, but we are using remotely operated vehicles, ROVs, autonomous underwater vehicles, AUVs, and even human-occupied submersibles to explore these environments in ways that we never could before.
So we're getting a clearer picture of what's down there, and hopefully that will help us figure out how to protect these amazing ecosystems.
Exactly. And there's another reason for optimism, I think, and that is the growing international collaboration among scientists who are studying these hydrothermal vents. By sharing data and expertise and resources, we can make much faster progress in understanding and protecting these unique environments.
It's amazing to think that scientists from all over the world are working together to unravel the mysteries of the deep sea. It's like this giant scientific treasure hunt.
It really is, and who knows what other incredible discoveries await us in those hidden depths.
Well, as we prepare to, like, resurface from this incredible deep dive, what's the one key takeaway you want our listeners to remember about hydrothermal vents and extremophiles?
I think the most important thing to remember is that life is far more resilient and adaptable than we ever imagined. These ecosystems, they challenge our very definition of what's possible, and they inspire us to keep pushing the boundaries of scientific exploration.
Beautifully said. And they remind us that even in the most extreme environments, life finds a way to not just survive, but to thrive. Who knows what other wonders are waiting to be discovered in those hidden depths?
That's the beauty of it. The journey of discovery never ends.
Well said. On that note, let's bring our submarine back to the surface. Thanks for joining us on this incredible exploration of hydrothermal vents and extremophiles. We hope you've enjoyed the journey as much as we have.
It's been a pleasure. Until next time, keep exploring the wonders of our world.